Okay, so yeah, so it's inclusive, so we can write this as pi, the solution is pi over 3 to, let me make that more obvious, to 5 pi over 3, and then, so that's gonna be the solution. Now, this is gonna be highlighting, so we want negative or 0. So you include the boundary, so that's gonna be from pi to 3, pi over 3. So that's gonna be a solid dot. Now, we can do some more practice problems. Let's do some more. Okay. Let's say we have, what number is this? This is 13. Let's say we have cosine of x minus root of 2 divided by 2 is greater than 0. From 0 is less than or equal to x is less than 2 pi. So now we can have cosine of x. Everything's already on one side, so now we can just make it into the equation. And now you have cosine of x is equal to root 2 over 2. And then this occurs at x is equal to pi over 4 and 7 pi over 4. So these are our boundary points. Now you can add the interval right here. Okay, yeah. So, yeah, you just draw 0 pi over 4, pi over 4, to 7 pi over 4, and 7 pi over 4 to 2 pi. So we can just mark those 7 pi over 4. Okay, great. So now we can start to test. Now to test, x is equal to pi over 6. Now cosine of x is approximately going to be a cosine of pi over 6 is approximately going to be equal to 0.866, which is going to be greater than root 2 over 2, just going to be positive, making it positive. Now x is going to be equal to pi, so yeah, that's going to be cosine of pi is going to be equal to -1, which is going to be less than or equal to root 2 over 2. It's going to be negative. Great. So now we have x is equal to 11 pi over 6 for each of our intervals. Okay, so we have cosine of 11 pi over 6. Yeah, so that's going to be that's going to be approximately equal to 0.866. So now that's going to be greater than or equal to root 2 over 2, and that's going to be positive. So on our intervals, you can mark this first interval as positive, this second one as negative, and then you can mark this last one as positive. So what we need is greater than or equal to 0. So that means you choose the positive and include the boundaries. So that makes the solution equal to 0 pi over 4 union of 7 pi over 4 the 2 pi exclusive. And now box that, and we can highlight that on our thing. So we have this to 7 pi over 4, 2 pi. So that's going to be exclusive. This is going to be inclusive, inclusive, inclusive. Okay, great. So now let's do another one. It's going to be slightly harder. So for this one, what question are we on? We're on 13. So, okay, this is going to be 14. So for 14, we have sine squared of x minus sine of x is less than 0. And this can be on the interval 0 is less than x is less than 2 pi. Okay, so everything is already on one side. So now the next course of action is, solving this. Sine squared x minus sine of x is going to be equal to 0. Great, so you have sine of x times sine of x minus 1. That's going to equal to 0. So now our boundaries are going to come from the zero product factors is going to be, that's going to be x is equal to 0 pi, and 2 pi. Now we have sine of x minus 1 is equal to 0. That means sine of x is going to equal to 1, and this occurs at x is equal to pi over 2. So those are our boundary points. So we can now create our interval right here. So we have 0, pi 2, and then we have pi 2 pi, and then we have pi 2 pi. So now we can mark those up, pi over 2 pi, and just like spread that over here. Okay, great. So now let's test these intervals. So for testing, we can do x is equal to pi over 4, and that is going to be sine of pi over 4 is gonna be equal to root 2 over 2, and that's approximately 7.07. And now plugging it into the function, we get 0.707 squared minus 0.707 is gonna be equal to this is the function, and that's going to be equal to approximately 0.5 minus 0.707, and that's going to be greater than 0. So that means you're going to get, that's going to be less than 0. That's going to be negative. So now on the next interval, we can pick x is equal to 3 pi over 4. Now picking 3 pi over 4, we get sine of 3 pi over 4. And yeah, that's going to be approximately 0.707, and that's going to be less, and that's going to be less than f, and that's going to be less than 0. So that means you get negative there. Now on our third interval, let's pick x is equal to 3 pi over 2. Now picking 3 pi over 2 gets sine of 3 pi over 2 is equal to -1. So therefore we get that f is going to be equal to 1 minus -1, which is going to be equal to 2, and that's going to be greater than 0, and then that's going to give us positive. So now on our map, we can now label negative, negative, and positive. So now we choose intervals. So we want less than 0, so we choose solutions are negative. So, and it's also exclusive, meaning no endpoints, and that is gonna be negative is gonna be right here, and that's gonna be exclusive. So that means we can write this in interval notation as 0 to pi. Great. And and the reason why we like going back to our boundaries, we exclude 0, pi over 2 pi, because inequality is strict, and f equals 0 here. So we don't include those. Okay, now let's do another question. That was 14, so let's do 15. Okay, let's say we have cosine squared of x minus 1 over 4 is greater than 0. It's going to be on the interval of 0 is less than x or equal to x less than 2 pi. So it's already on, everything's already on one side. Great. So now we can do cosine squared of x is going to be equal to 1 over 4. Taking the square root of both sides, we have cosine of x is going to be equal to plus or minus 1/2. And now we're going to ask ourselves, where is cosine x equal to positive 1/2? And where's cosine x equal to negative 1/2? Okay, so positive 1/2, that's going to be at x is equal to pi over 3, and also at 5 pi over 3. And this is going to be, cosine x is going to be equal to negative 1/2 at 2 pi over 3 and 4 pi over 3. So Now these are our boundary points. Okay. Again, we can draw this up here. Now we have intervals of 0, pi over 3, pi 3, 2 pi over 3, 2 pi over 3, 4 pi over 3, 4 pi over 3, 5 pi over 3, and we have 5 pi over 3 to 2 pi. So now I guess we can label these pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now, okay, now we're gonna test some points. Pretty long inequalities. So yeah, we're gonna have 5 intervals. So we have, for our first interval, let's try x is equal to pi over 6. That's gonna give us cosine is equal to, cosine pi over 6 is gonna be equal to root 3 over 2. So then the equation would give us cosine squared is, I guess, gonna be equal to 3 over 4. So then we get g is gonna be equal to 3 over 4 minus 1 over 4 is equal to 1/2, and then that's gonna be less than, it's gonna be greater than 0, so that's gonna be positive. So let's say that we have x is equal to pi over 2. So that's gonna make cosine of pi over 2 is gonna equal to 0. So that means that g is gonna equal to negative 1 over 4, which is gonna be less than, or is gonna be less than 0, and that's gonna be negative. Now, okay, let's say that x is equal to pi. So that means cosine of pi is just gonna equal to negative 1. So then you have cosine squared is equal to 1. So then you have g is equal to 3 over 4, and that's going to be greater than 0, so that's going to be positive. And so you have x is equal to 3 pi over 2, and then that's going to be cosine of 3 pi over 2 is equal to 0. So you have g is less than 0, so that's going to be negative. Okay, now for our final interval, we have x is equal to 11 pi over 6, and then we have cosine 11 pi over 6. That's going to be equal to root 3 over 2, and then that's going to give us g is greater than 0, and that's going to be positive. Okay, so now for our intervals, we can label this as positive, negative, positive, negative, positive. And we want our solutions to be greater than 0, so that means we want the positive solutions. So therefore, that's going to be 0 pi over 3, and then that's going to be union 2 pi over 3 times 4 pi over 3, union 5 pi over 3, 2 pi, and yeah, so we can box that up. Now you can highlight on the thing 0 pi over 3. Okay, now 2 pi to 4 pi over 3. Okay, let's make that a little neater. There, and then 5 pi, 3 to there. And then this is, all these are going to be exclusive. So those are going to be open circle on all of those boundaries. Now, let's do another example. Okay, so that was question. So for question 16, we have 2 cosine squared theta plus sine theta less than 0, and that's going to be on the interval of 0 is less than or equal to theta is less than 2 pi. So now move everything to one side. Everything is already on one side, so now we can set this to as an equality instead of an inequality. It's going to be 0, and now we can rewrite cosine squared theta is equal to 1 minus sine squared theta. So right here we can write this here so we can see it. 1 minus sine squared theta, and that's derived from the fact that cosine squared theta plus sine squared theta, with the fundamental Pythagorean identities you need to know, Okay, so that's going to be 2 times 1 minus sine squared theta plus sine of theta, and that's going to be equal to 0. And then you can distribute that. Then you get 2 minus 2 sine squared theta plus sine theta. That's going to equal to 0. Great, so now we can rearrange this. So now this is in the form of a a quadratic equation. So we can do u sub, just to make it easier on our eyes. Let u is equal to sine theta. So then you get 2u squared minus u minus 2 is equal to 0. Great, so now you can do the quadratic formula because it's unfactorable. So you get u is equal to 1 plus or minus 1, okay, great, negative 1 squared minus 4 times 2 times negative 2, now over 2 times 2. That's going to equal to 1 plus or minus 1 plus 16 divided by 4. That's going to equal to 1 plus or minus 17 over 4. Now, let's do our positive and negative cases. So this is for... Now this is going to be approximately 1.28, and this is going to be approximately negative 0.781. But this is not possible, but this is actually possible. So that means only one boundary solution satisfies. This. So we can call this value k. So that's sine theta is going to be equal to 1 minus 17 over 4. So that means we can just call this k. K is equal to 1 minus root 17 over 4, where k is going to be greater than 0. So there will be 2 angles. No, but we know that there's going to be 2 angles in 0 to 2 pi, where theta is going to equal to k. So that's going to be 1 in Q3 and 1 in Q4. So we can label those as theta 1 is equal to pi minus arc sine of k, and that's going to be for Q3. And then we have for theta 2, this is going to equal to 2 pi plus arc sine of k. And then this is quarter 4, since arc sine of k is going to be less than 0, and that's the exact form, no decimals. So that means our boundary points are going to be this. So yeah, this is going to be a little bit messy. So yeah, okay. Our boundary points are going to be theta 1 is equal to pi. Yeah, those are our boundary points right here. And that's where k is equal to this. And now we can split our interval into parts using this. So we just can write it here as 0 to theta 1, theta 1 to theta 2, and theta 2 to theta 3, or not theta 3 to 2 pi. And now we have to label the sign of f of theta is equal to cosine squared theta plus sine theta. So label the sine of, okay, and now after this, now we can test some points. So for the first interval, we can test the point. We can do theta is equal to pi over 2. So then we have 5 theta over 2. That's going to be equal to 2 times 0 squared plus 1. That's going to be equal to 1. And that's be greater than 0. So that's going to be positive. And then for the second interval, we can choose theta is equal to 3 pi over 2. So then we get f of function of 3 pi over 2 is equal to 2 times 0 squared plus negative 1. And that's going to be equal to negative 1. And that's going to be less than 0. So that's going to be negative. And now in the final interval, we can choose theta is equal to 7 pi over 4. So we can do the function of, or we can just write it as this, cosine squared 7 pi over 4. That's going to be equal to root of negative 2 of just 2 squared. And then we have sine 7 pi over 4, and that's going to equal to negative root 2 over 2. Now for the function, it's going to be equal to 2 times 1/2, and then minus root 2 over 2. That's going to be greater than 0, and that's going to be positive. And now in the map, we have theta 1 and theta 2, and now that's going to be positive, negative, and that's going to be positive. And now we want solution is going to be f of theta is less than 0, so we want negative solution, so we want and it's also going to be exclusive, so that means that it's just going to be pi minus arc sine of 1 minus root of 17 over 4, and then that's going to be 2 pi plus arc sine 1 minus root of 17 divided by 4. And yeah, now let's do one more problem. That was question 16, so that's, we're gonna do question 17. So let's say that we have sine of x times cosine of x is going to be greater than or equal to 0, and 0 is going to be less than or equal to x, and then 2 pi. So now, when does this happen? Yeah, so you can just set each of these equal to 0. So we get x is equal to 0, pi, 2 over pi, and then we get x is equal to pi over 2 and 3 pi over 2. So those are going to be our boundary points. And okay, oops, this is not what I meant to do. So we can copy over this chart. Now we can do 0. Okay, so now we can label these points. This is going to give us interval of 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, 3 pi over 2 to 2 pi. So let's draw those pi, 3 pi over 2, boom, boom, done. Okay, so now instead of computing values, we can use sine rules for sine and cosine. So we know that in Q1 we have positive sine and we have positive cosine. Therefore, the product, you can actually set this up as a little neat table. Q2, Q3, and Q4. So the product would be positive, and then here we have positive sine, negative cosine, and then we have negative sine, and we have negative cosine, and we have negative sine, and then positive cosine, and then product is going to be negative, positive, and negative based on exact positivity. And now we have this as our intervals. So we're gonna have positive, and then this is gonna be negative, and this is gonna be positive, and those are all our intervals, right? Yeah, so negative, positive. Okay. Let me see. And that's gonna be negative. So we want our solution is gonna be greater than or equal to 0. So that means we want positive. And we also, it is inclusive to where product equals 0. So that means that our solution is gonna be 0 pi over 2 union pi 3 pi over 2. Now we can highlight this on here, 0 pi over 2 all the way from pi to 3 pi over 2. So we can highlight those great like that. And yes, so yeah, that's gonna be how it's gonna look like. That's it.